Welcome back, everybody. In today's lesson, we're going to focus in on inequalities, and we're going to be using inequalities that use addition and subtraction. A reminder that the prefix in right here means not equal. So these are expressions that are saying that two sides of the expression, two sides of the inequality are not equal to each other. And we're going to focus on using addition and subtraction only today. So today your objective is to be able to solve inequalities that use addition and subtraction. And you'll also be asking yourself, how is solving inequalities with addition and subtraction similar to and different than solving equations with addition and subtraction? I'm going to introduce the do now, but you're going to complete this on your own. So in the do now, it says that Selena and Martin are waiting at the bus stop. The number lines show the possible wait times in minutes, T, for Selena and Martin. So for Selena, her sign says bus every 15 minutes. And for Martin, his phone says that the blue line bus is delayed. And his number line shows that it could be more than 15 minutes. So here are two number lines. Her number line is saying it could be 15 minutes or less. His number line is saying that it's going to be more than 15 minutes. And you have two questions to answer on your own. So this is on your own. And this is also going to be done on your own. So you have to decide who anticipates a longer wait. Justify your response with a mathematical explanation. And then if Selena and Martin both wait 10 minutes for the bus, whose possible wait time was closer to his or her actual wait time? And so you're going to answer both of those questions in the boxes that are provided. You can do that now and press pause, or you can do that at the end and at the end of the video and do this at the end. Or you can pause the video and do it right now. Alright, when we talk about inequalities, there are different symbols that we use. We call these the inequality symbols. We just finished talking about equations where we use the equal sign. That means that the two sides of the equation are equal to each other. When we deal with inequalities, we're using inequality symbols. And so these are all your inequality symbols. Okay, so these are all your inequality symbols. This symbol is called less than. And so when we see words like is less than or is fewer than, that's the symbol that we use. It says Tracy has less than 20 pairs of shoes. That's the symbol we would use. It's the less than symbol. This is the less than or equal to. So less than or equal to. So the words that mean that give it meaning are is less than or equal to, is no more than, and is at most. That can be a little confusing because we're using the word more and most for a symbol called less than. But think about it this way. If the amount we're talking about is not more than something else, that means it has to be less than that number. So it has to be either less than the number or equal to that number if it can't be more than that number. So those are the only choices. It's either got to be more than, equal to, or less than. And if we're saying that it can't be more than, then it has to be either equal to or less than. It says the maximum capacity of the auditorium is 1,000 people. So that's an example where we would use the less than or equal to symbol. This is the greater than symbol. So that means it's greater than, or it's more than, or it exceeds. So that means that it's the greater than that amount, or it exceeds that amount. It's not equal to that amount, or it's not less than that amount. So Kelly owns more than 200 DVDs. That means that the amount of DVDs she owns is more than 200. It's not equal to 200. It's not equal or less than 200. And this is the greater than or equal to symbol. So greater than or equal to. We use words like is at least or is no less than. So is greater than or equal to is at least that amount. It could be more. Or is not less than. Again, that can be confusing because we're using words like less and least for a symbol called greater than. But remember that we're saying it's at least that amount, but it could be equal to it or greater than. We're saying that it's not less than. So it could be greater than or equal to, but it's not less than. When we graph on the number line, we have two different dots that we could graph using. So if we have a colored in dot, it means that that number is included in the answer. And if we have an open dot, it means that that number on the number line is not included in the answer. And we saw that over here in the do now. So in Martin's number line, the dot was open. So that means that it's going to be a more than 15-minute wait. It's not going to be 15 minutes, and it's not going to be less than 15 minutes. It's going to be more than 15 minutes. So anytime more than 15 minutes, that's why it's an open dot. For Selena's, it could be 15 minutes or it could be anything less. So that's why the dot is colored in, is because 15 minutes is a possible amount of wait time. Okay, so looking at the first few examples together, we're looking at an example where we're writing an inequality that uses addition. So it says on the airline that rule is using the weight limit for both suitcases combined is 50 pounds. How much can Rule's second bag weigh without going over the limit? So over here it tells us how much the first bag weighs, and we can't go over the limit, and combined they are 50 pounds. So when we write the inequality, it doesn't tell us what variable to use. So I'm going to use x. So that's x right there. That's the first bag. So the first bag plus the 38 pounds. And now I left a blank here because we have to figure out what symbol goes here. So can the two suitcases together be more than 50 pounds? Well, it says that the combined weight has to be, the weight limit is 50 pounds. It says the bags can't go over the limit. So we're not going to use one of these symbols that's greater than. So we're going to end up using one of these symbols for less than. Now, could it be exactly 50 pounds and that be okay? It says it can't go over the limit, but could it be right at the limit? So if yes, and in this case it is a yes, we want to put a less than or equal to symbol. When we solve inequalities like this, we do the same thing as before. So if you build flowcharts, it's just going to be a little baby flowchart with one arrow. It's going to say plus 38 with 50. Minus 38. And x is less than or equal to 12. If you did balancing, it would just be a shorter version of the balancing method. Alright, now if we come over here, we have to put a dot at 12 because that's part of our answer. Now, is 12 less than 12 or is it 12 equal to 12? In other words, is 12 a possible weight of this bag? So could this bag be 12 pounds? If yes, then we want a colored in dot at 12. And if no, then we want to have an open dot at 12. So in this case, we want a colored in dot at 12. And then we're going to shade in every other weight that's less than or equal to 12. So we're shading in everything that's less than or equal to 12. Okay, you're going to do this try it question on your own. And now we're going to try out the subtraction questions. So it says the weather forecast predicted that the evening temperature could get as low as negative 12.5 degrees Fahrenheit. Between afternoon and evening, the temperature dropped by 7.5 degrees Fahrenheit, which was consistent with the forecast. What could the afternoon temperature T have been? So I have to use the variable T. It says that the temperature dropped 7.5 degrees, so that means subtract 7.5 degrees. And then the other number was negative 12.5 degrees. So now we have to think about, okay, so the temperature said it could get as low as negative 12.5 degrees. When it says it could get as low as negative 12.5 degrees, that means that that's the lowest it could be, but it could also be anything higher. So it could be higher than negative 12.5 degrees, or exactly negative 12.5 degrees. And that's how you want to think about it. You want to ask yourself, okay, could it be higher? Well, when it says as low as negative 12.5, that means that that's the lowest it could be. So since that's the lowest it could be negative 12.5 degrees, or it could be something higher than that. Alright, so you can build your flowchart or a balance. I'm going to do balancing method here. So I'm going to do plus 7.5. So we have to find it there. Alright, so we have t is greater than or equal to negative 5. So we come over to the number line. And since it says t is greater than or equal to negative 5, sorry, that means that we're going to have a colored in dot. And we're going to color in everything that is greater than or equal to negative 5. Okay, So here's what you've got to do. Oh, yeah. So here's what you've got to do. So you've got to go back to the do now and do this on your own. You've got to do number 4 on your own and number 6 on your own. These 2 questions on the back are optional. But you do have to do the do now. So let me just write that down. So you've got to do the do now. Four, 6, and 9. Alright, so you've got to do the do now, 4, 6, and 9. You're going to show that so we can correct it and check it off. So you're going to show that to us, have it corrected, and then we'll check it off as being done. And then you're going to go back to Google Classroom and work on this activity. So in this activity, what you're doing is you're finding cards and matching them together. You're going to have inequality cards, solution cards, and then graphs of graphing cards. And here's an example of what it's going to look like. So you're going to have the number is going to be the inequality card. You're going to write the solution like this in this line. And then you're going to put the capital letter of the graph card here in this line. Okay? And how we're going to check it is we're going to check to make sure that your solutions are correct. And then to make sure that your letter or your graphing cards are correct here. So this is what it looks like. These are your inequality cards. So you would take each one, you would build your flow chart or use the balancing method. Then you would go and find the solution card, and then find the graphing card that goes along with it. And that's what we're going to be checking off, is to make sure that these are all written correctly and that all of your graphing cards are listed correctly. Okay, let us know when you're done so we can check off your work. Again, we're checking off the do now, 4, 6, and 9, and then you're going on to that activity.